Okay, watch and listen carefully here, guys. We're just going to real quickly go through this because we should be pretty familiar with all this stuff already. Okay, for number 1, we've got an ionic compound. I know it's ionic because magnesium is a metal and hydroxide is a polyatomic ion. So this stuff is magnesium hydroxide. No capital letters. It's got to look, well, neater than mine, but spelt the same. Okay, magnesium hydroxide. Okay, for number 2, silicone's a non-metal, so I'm looking at a molecular compound, which means I've got to use prefixes. So we've got disilicone, trinitride. Okay, again, no capital letters. For number 3, I've got cobalt, which is a metal, okay, with oxygen, which is a non-metal. All right, so I'm going to have cobalt oxide. However, cobalt has more than one possible charge, so this name requires Roman numerals. Since oxygen is always a -2, there are a total of 6 negative charges. Okay, so that means there have to be 6 positive charges coming from 2 cobalts, which means cobalt is +3. So this is cobalt, Roman numeral 3, oxide. Questions on any of those? Okay, for the formulas here for 4 through 6. Copper 1 sulfate. So the symbol for copper is Cu, and the Roman numeral tells us use the +1 charge when we swap and drop. Sulfate is SO4, and it has a -2 charge. So we are looking at Cu2 SO4. Okay, for number 5, we got oxygen monosulfide. Molecular compound. So there's no prefix in front of oxygen, so how many are there? 1. And how many sulfurs are there? 1. OS. Okay, and hydrogen phosphates. If hydrogen's listed first, it's behaving as a metal. That means this is an ionic compound. Whoop, it's not 3+ though. It is 1+. Okay, and phosphate, which is PO4, is -3, right? Yeah. Okay, so we've got a drop and swap, so the 1 goes there, we don't write 1s, and the 3 comes here. We got H3PO4. Questions on those 3? Okay, for the fill in the blank parts here. A solid produced in a reaction that will not dissolve is a what? Precipitate. All right, any substance that will dissolve another substance, so it's doing the dissolving, that is a solvent. Okay, and the substance that is dissolving is the solute. Okay, when water forms hydrogen bonds with itself, we call this process cohesion. The reason I say one word is so that people don't write hydrogen bonding, thinking they're so clever. Okay? Yeah. All right, number 11. We got to use the solubility chart for this one. Can I get someone to close the door? Jen, could you just close the door for me? Thanks. Okay. So for our first one, I guess I better look at what it is first. Okay, we've got magnesium nitrate. Well, pretty much all nitrates are soluble, but we'll just double check. Nitrate's right here, soluble with most things, and I don't see it down here in the second row. Okay, so that one is soluble. S for 1 mark. Okay, for B, we've got mercury 2 sulfate. Okay, so we're going to look up in our solubility chart. Sulfate says it's soluble with most things, but I do see mercury 2+ listed down here. So this is not soluble for 1 mark. Okay, we got sodium phosphate as our next one here. So we look up phosphate. It's right here. Says it is soluble with sodium. Okay, so that one is soluble. Okay, and lithium fluoride. Okay, so we look up fluorines right here, soluble with most things, but lithium is the first thing listed in the not soluble row. So this one is not soluble. All right, it's out of 13. Please give them a mark out of 13. Let them see it, and then put it in the top box, please. All right. Yesterday we started talking about chemical reactions, and we went over the 5 kinds of chemical reactions. Synthesis. Okay? And in a synthesis reaction, we have 2 elements combining to form a single compound. We went over decomposition. Okay? In a decomposition reaction, a single compound breaks down into its 2 elements. Okay? We looked at combustion reactions, where any hydrocarbon, that's something that has carbon and hydrogen in it, reacts with oxygen to produce carbon dioxide and water. Okay? And then we looked at the 2 replacement reactions, double replacement and single replacement, that involved ionic compounds. Okay? So what we're going to do is continue on with that, but we didn't get done the last one here. I kind of just glazed over it at the end of class yesterday, so I just want to quickly go over this one. Okay? And then we'll look at a few more examples and kind of get started on some practice. Okay? Now, this last reaction has all of what kind of compounds in it? Ionic or molecular? They're all ionic, okay? If hydrogen's listed first, it's behaving as a metal, so hydrogen chloride, okay, that's an ionic compound, okay? Potassium hydroxide is an ionic compound. Water, sort of ionic, it can behave that way, at least especially if it's written this way, okay? And then we've got potassium chloride, also an ionic compound. So we got 4 ionic compounds, which means this is what kind of reaction? It's a double replacement reaction. Okay? And in a double replacement reaction, we swap the metals, and we see that that's exactly what's happened. The hydrogen paired up with hydroxide, okay? And the potassium paired up with chlorine on the product side. So we got 2 new ionic compounds. Now, when we see that a reaction has no subscript numbers, okay, that's the little numbers, that means everything is a 1, right? There's 1 hydroxide here, there's 1 hydrogen, there's 1 potassium, there's 1 chlorine. If everything is a 1, is it already balanced? Yeah, okay? So in that way, that kind of balancing is pretty easy. Here's the only problem with a reaction that is already balanced as 1s. If you get this on a quiz or a test as a fill-in-the-blank question, don't leave it blank. Okay? I have people who do that all the time. And then what do I have to assume when I come to market? He didn't do it. Okay? If you leave it blank, I just have to assume you didn't know what to do. And don't make me make that assumption. What could you write in front of every one of these? 1, yeah. Okay? So if they're all 1s, make sure you write a 1 in front of every single one of them to tell me, hey, Coder, I didn't just leave this blank. I knew they were all 1s, so I wrote them for you. Okay? Yeah? Everyone follow me there? Because I've had that happen on a unit exam in the past, and a bunch of people are like, Mr. Coder, you marked this wrong. I'm like, well, you left it blank. What am I supposed to do? Well, it was already balanced. Yeah. Okay. Tell me it was already balanced by writing 1s in all the blanks. Okay. Everyone follow me on that? Okay. That's kind of the only situation where you'd really have to write 1s. Most of the time you don't. Okay. But if they're all 1s, show me you actually did the problem. Okay. Now, quick review here of the balancing. I'm just going to make up a reaction. You guys can write it down as another example here, and we'll kind of run through the process. So let's say we've got okay, what kind of reaction is this? Just looking at the reactants. I have an ionic compound, and it's reacting with an element. Someone whispered it. It's a single replacement reaction. Now, the thing that's alone, is it a metal or a non-metal? It's a non-metal, right? Bromine is on the other side of the staircase. Now, that means that bromine has to replace sulfur or magnesium. It's got to replace sulfur, okay? Because we said yesterday, we have to end up with an ionic compound on the other side. We can't have 2 nonmetals together. We can't have 2 metals together, okay? So, on this side here, magnesium will end up with bromine, and sulfur will end up by itself. Now, what do I have to do with that ionic compound? Is this compound right the way I've written it? No, it's not, because I haven't swapped and dropped it yet. Okay, so it's MgBr2. That's looking nice for balancing right up until this point. Is sulfur special? Is it highlighted on your periodic table? It is. In orange, right? Which means it comes as an 8 when it is by itself. So much for the nice balancing. Okay, so there's 8 sulfur. What should I start balancing first? We said yesterday if it's not a combustion reaction, we should start with the largest number, which would seem to be 8. All right, so there's 8 sulfur on this side. I've got to come over and make 8 sulfur on this side. So where do I put an 8? Right, in front of this, right? I can't just do this, because that's not how that compound works. Okay, I've got to put a big 8 right here. Now, how many magnesium does that give me? 8, yeah, so now I got to go over here and put an 8 there. All right, now that gives me how many bromine? 16, so I got to go over here and put an 8. Now it's balanced. Okay, is that ringing a bell? All right, now we'll do one more example here because these sometimes had special rules. What kind of reaction is that? It's a combustion reaction. I have a hydrocarbon, something containing carbon and hydrogen, reacting with oxygen gas. The products of a combustion reaction are always carbon dioxide and water. Okay, there's 2 special rules for balancing a combustion reaction. I always balance in what order? Alphabetical. And the second rule? Yeah, 2 first. Yeah, we call it the rule of 2. Is there an even number of carbon atoms here? Okay, if there's an even number of carbon atoms, I start balancing with a 2. Okay, that's why we call it the rule of 2. Even number, start with a 2. Okay, now I'm going to balance in alphabetical order. How many carbons are there here? 4. All right, so I'm going to go over here and write a 4. How many hydrogen are there? 12. Okay, so I'm going to go over here and put what in front of water? 6. Okay, now I've got to count up my oxygens. 4 times 2 is 8. Okay, and 6 more is 14. Okay, so what times 2 will give me 14? 7. Okay? So there's those little things, and that's why we spend so much time practicing reactions, is there's just those little rules, little exceptions that we have to kind of commit to memory. Okay? Any questions on that stuff from yesterday? Okay, I'm going to give you a couple of worksheets here that we're going to start on. If you have questions today, ask. Okay? If it's the first day we're working on it, you're probably going to have them. Ask. Okay? Make me walk all over the place and answer lots and lots of questions because we want to make sure we get this, okay, as quickly as we can. All right? How many of these should you do before you check your key? I would say each reaction, check your key. It's not like doing the naming. Okay? Each time you do a reaction, check the key. Where can you find the key? Okay, the key is on my website. All right, if you go, okay, to the website, you click on Science 10 stuff right here. Okay, same place where everything is. Okay, click on the chemistry folder. All right, and then you'll want to go down to where it says Keys to All Reaction Worksheets, which is, and I'm missing it apparently. All right, I will have to put it on there. I can't believe I'm missing that. Okay, I will put it on there right away, and then you'll be able to check it as you go. Okay, all right, first I'll give you the worksheets though. Okay, they're all there now. All right, so if you go into that chemistry folder now, okay, and just expand it, they're going to be near the bottom. All right, so expand the chemistry folder and then scroll down, okay, past all the stuff that starts with chemistry, and you'll see, okay, key for chemistry exam review, which you don't need yet because it's for the review sheet that I give you, okay, and then keys to all mole equation worksheets, which you don't need yet either. Keys to all reaction worksheets, that's the one you're going to want to look at, okay, for the keys to what you have. Now, talking about what you have in front of you, okay, really quickly here. Okay, you have this thing right here in front of you. Right? The first one is done for you, but here's what we're looking for. Basically what we did yesterday. Balance the equation. Okay, write the word equation, so essentially name everything that's in the reaction. So you can see here I've written iron plus hydrogen chloride gives iron 2 chloride plus hydrogen, okay? And identify the reaction type. Because there's an element reacting with an ionic compound, this is a single replacement reaction, right? So that's what you do for each one. Taylor, question? A decomp and a synthesis? They're the opposite of each other, okay? So we'll just go back here. In a synthesis reaction, I'm putting two things together to make a compound. In a decomposition reaction, I've got a single compound going to the two things it was made up of. Yeah? Okay. Okay, so everyone good with that? I'll give you a few minutes and we'll do a few. Okay. All right, so if we're looking at number 3 here, guys, we have a reaction where we start out with just one compound. Okay? There's only one reaction type that starts that way, and it's what? Simple decomposition, right? We can only decompose a single compound. It can't react with anything if that's the only reactant. Okay? So we're looking at a decomposition reaction. Okay? And now we got to write it out in words, so this stuff is water. Okay? And it's breaking down into hydrogen and oxygen. Okay? Now for the balancing part. Okay? Hydrogen's already balanced, but oxygen is not. There's 2 oxygen on the product side, and there's only 1 over here. So in order to make that work, I've got to make more water. All right? So I've done that, but that now gives me 2 times 2 is 4. Okay? Hydrogen atoms, so I need a 2 here in order to make that work. Okay? Does that make sense? Okay? Any others? Yep, which one? Oh, yeah, just write water. It's an old key. Yeah, just write water. Yeah. Yeah, guys, anytime you see H2O, HOH, just write water. Okay, that's what it is. You don't have to write dihydrogen monoxide or hydrogen hydroxide or whatever you want to name it. Just name it water. Okay, that's what it is. Okay, guys, just want to go over number 5 here, because number 5, questions like number 5 come up, and there's kind of an easy way or a little thing you can remember that can help you with questions like this one that are a little bit tricky, okay, in terms of the balancing. Okay, number 5 has what we sometimes call in science 10 the odd-even problem. Okay, there's an odd number of oxygen on one side, and there's an even number on the other. All right, and so it's hard to get that to balance out. So what's the quickest way to make an odd number even? What can you do with an odd number to make it even? Multiply it by 2. Okay, so if you run into that problem, because probably what most people would have done here is, oh, well, there's 2 aluminums here, they put a 2 here and then go, oh, well, that really didn't work, because now I still have this problem with oxygen. So if you run into that problem, double the side that's odd. Okay, so in this case, I'm going to double this compound to get rid of my odd number. When I do that, it gives me 4 aluminums, so I go back over here and put a 4 there. Okay, and it gives me how many oxygen? 6. So then I go over here, and now I can in fact balance this 4, 3, 2. Okay, it happens from time to time, so the quickest thing to do is to just double the odd side, double the odd molecule, and then usually from there it'll work out. Okay, so just a little strategy for that one. Any others you got questions on? 8? Yeah, 8's tricky. Same problem. It's got the odd-even problem. All right, so first off, we've got 2 things going to form one thing. Now, we said that usually when that happens, it's going to be 2 elements forming a single compound. But is it okay if it's a compound and element and then a single compound? Is it still the same type? This is still a synthesis reaction. The reason it's still a synthesis reaction is we only have one product. Okay, so in that case, this is still a synthesis reaction. Now, in terms of writing it out, that's a little bit trickier, because you'll see that sometimes these things appear in your table of polyatomic ions. Okay, do you ever find an ion by itself, or is it always in a compound? It's always in a compound. All right, so I have to name these like they're actually a compound and not with their ion name. So this is sulfur dioxide. Okay, and it's reacting with oxygen. And it's producing sulfur trioxide. Okay, so all molecular stuff. Now, for the balancing part, on this side here, I've got 3 oxygens, but on this side, I've got 4. All right, now, that's not great. The lowest common multiple of 3 and 4 is what? Is 12. Okay, I could go with that, but I'll probably end up reducing it after. We just said that when you run into that problem, a good way to solve it is to double the thing that is odd. Okay, so I'm going to put a 2 in front of the SO3. Now, that gives me 2 sulfur. Agreed? All right, so I got to come back over here and put a 2 in front of this. Agreed? Okay, now, I've got 6 oxygen on this side, 2 times 3. And I have 2 times 2 is 4, plus 2 is 6. Okay, so that odd-even thing usually works. If you put a 2 in front of the thing that's odd, you'll generally get it to balance. Okay, now, if you went and found the lowest common multiple, okay, which is 12, you probably would have run into this problem. You would have gone, all right, this needs to be 4, so then I got to go over here and make this 4, and then you would have had this. You'd had 4, 2, 4. Can you reduce 4, 2, 4 down? Yeah, it ends up being what we had a minute ago, which is 2, 1, 2. Oop. Okay, that's probably about as hard as they get in terms of being tricky balancing. Any other ones giving us trouble? Okay, don't be afraid to ask if there are. Okay, guys, so another good question just came up here on number 9. Number 9 is another one of those odd, even types of questions. So if we're looking at this here, we've got another synthesis reaction that involves a compound in an element. And again, those are rare, but they do happen. Okay, in this case, it's carbon monoxide plus oxygen gives you carbon dioxide. Okay, but for the balancing, I've got 3 oxygens on the reactant side, but only have 2 on the product side. And we always said if you got that odd-even problem, you should double the compound that has the odd number in it. Okay, so I double carbon monoxide, and that gives me now 2 carbons, 2 oxygens. Okay, 2 oxygens over here. So if I put a 2 here, that balances my carbons, and it balances my oxygens, because I have 2 oxygens here, 2 there, that's 4. 2 times 2 is 4, and it works out that way. Okay, so again, when you have that odd-even problem, put a 2 in front of the thing that's got the odd number, and generally it works out from there. Any other ones giving us trouble? Okay. Probably a lot of you aren't here yet, and that's okay, but I just want to illustrate something here that comes up occasionally, and it's on F, all right, where we have sodium reacting with water to produce sodium hydroxide and hydrogen. Oftentimes when you have water in a replacement reaction, it splits up into hydroxide and hydrogen, and it becomes hard to track where everything is gone. Is there another way to write water that might make it easier to follow where this OH came from? Right, write it as hydrogen hydroxide. Now following where everything went becomes quite a bit easier. I know the OH went here and this H ended up over here. So when I do my balancing, it's a little easier to figure it out. So if you see water on one side written as H2O and you see hydroxide on the other, cross off H2O and write it as HOH, and you'll have a much easier time tracking where everything goes. Okay? You can. Okay, guys, I think there's a mistake on my key for number 3. Okay, so just have a look here. We got aluminum reacting with oxygen to produce aluminum oxide, and I don't think I swapped and dropped right on mine. Okay, this is -2, this is +3, so this should be Al2O3, and I don't think it looks like that on my key. Okay, so just double check here. This should be Al2O3, which means, okay, that we have to double the odd side, okay, to give us 6 oxygens and 4 aluminums. Okay, so it should look like that. I don't think it looks that way on the key, so that is the correct answer. Right? A lot of people have come up to me and shown me that answer, which is correct, not the one that's on my key, which was a brain fart on my part because it's wrong. Okay.